In this video we're going to determine the equation for the reaction between magnesium and hydrochloric acid. Now first of all, I apologise for the background noise. It's a video in another room about applications for college. So let's try and ignore it. Now to do this, to get the equation, we need to know accurately the amount of magnesium we're using, the amount of hydrochloric acid and the amount of hydrogen that's formed. Fortunately, we can't measure simply the amount of magnesium chloride formed. So without further ado, this is our top man balance, and the reason why we're using this is that we can measure accurately to 2 places of decimals. So our mass of magnesium is 0.08 grams. So coming back here, we'll put this onto our sheet, 0.08 grams. I've measured out our hydrochloric acid. Now hydrochloric acid, I'm going to use 8 centimetre cube of 1 molar hydrochloric acid, and we will measure our volume of the gas produced. This is our apparatus setup. We're going to do the reaction between the acid and the magnesium in a boiling tube. The hydrogen that's been produced will pass up through this bung into the delivery tube and will be collected in the gas syringe. The reason why we're using a gas syringe is because we can very accurately measure the volume of gas produced. So let's get started. So I'm adding the acid, and immediately then I'm getting the bung in to collect the gas produced. Now, as you can see with the gas syringe, this line tells you the volume of gas being produced. As you can see, it's being pushed out as the hydrogen reacts with the hydrochloric acid to produce hydrogen gas. Now what we're looking to measure is how much gas is produced in total. As you can see now, the reaction is finished. All the magnesium has been used up. So let's get the volume of hydrogen produced. So looking at our gas syringe, you can see it's not moving any further. And looking at the measurement, we've got 80 centimetre cube of hydrogen produced. So let's go back to our table here now. 80 centimetre cube, and let's just put that on. Now, what we need to do is work out how many moles of each we've got. So to do that, to get our moles of magnesium, we divide by the relative atomic mass. So the relative atomic mass of magnesium is 24. So 0.08 divided by 24 equals 0.08 divided by 24 equals 0.0033 moles. Now I know that our moles of hydrogen will be of hydrochloric acid will be 0.08 moles, and to get our moles of hydrogen we divide our 80 divided by 24,000 . And that comes out as 0.0033 moles. Now then, what we need to do now is divide each by the smallest. So the smallest of our results is 0.0033. So 0.033 divided by 0.33 is 1. So 1 mole of magnesium gives you 1 mole of hydrogen, and 0.008 divided by 0.0033 equals 2.4. Now, what that effectively means, if we put this into a simple equation, Mg plus HCl goes to MgCl2 plus H2. Now, effectively, this means 1 mole of magnesium, take it to the nearest number, it reacts with 2 moles of hydrochloric acid to give you 1 mole of hydrogen. Now, if we check this, 1 magnesium atom, 1 magnesium atom, 2 hydrogen atoms, 2 hydrogen atoms, 2 chlorine atoms, 2 chlorine atoms. As you can see now, this equation is balanced, and we've done this by accurate measurements of mass and volume, and being able to work out the number of moles of each of the substances involved. And the equation is really just a ratio of moles of reactants and products. So you can do this with all sorts of equations to better check them.